Today we're going to take a look at the beautiful yet infernal planet Venus. Let's delve into what makes this planet so unique in our solar system. So buckle up and come with me till the end. We're going to unravel some of the mysteries of this fascinating planet called Venus. Visually, it's a very beautiful and elegant planet. Seemingly very calm and almost tranquil on the surface. From an outsider's perspective, it's clear why it was named Venus, the goddess of love in Roman mythology. Dive beneath the cloud layer and you'll find quite the opposite. Scorching temperatures, volcanism, and an overwhelming atmosphere are all you'll find on the surface. But let's step back a bit and see where this planet fits into our solar system. Venus is the second planet from the Sun and is our closest neighbor. Its average orbital radius around the Sun is 72 cents or approximately 108 million kilometers. It doesn't vary much from this average orbital radius as it's the planet with the least eccentric orbit, orbiting almost in a perfect circle. Venus at its closest to us is a mere 41 million kilometers away. Interestingly though, this occurs not when it's brightest in the sky. At its closest approach, we see only its night side when it lies between the Sun and the Earth, showing only its dark side. However, it's still visible as sunlight refracts through the atmosphere. In fact, it's brightest when it appears in a thin crescent shape in the sky, and when it does so, it's the brightest object in the night sky after the Moon. As such, Venus is commonly misreported as an unidentified flying object (UFO). American President Jimmy Carter reported seeing a UFO in 1969, and later analysis suggested it was likely Venus. Numerous other individuals have mistaken Venus for something more exotic due to its striking brightness. Notice in this image captured by a telescope the detail of Venus's brightness and its sharp, visible crescent shape. With Venus orbiting between us and the Sun, you might wonder if Venus eclipses the Sun from our viewpoint on Earth, and the answer is yes, but surprisingly, very rarely. Transits occur in pairs, with the pairs separated by 8 years, but all pairs occur only once every 100 years. The last transit we had was in 2012, but if you missed that event, the next one won't occur until 2117. The reason for this rarity is because Venus's orbital plane isn't exactly the same as Earth's. Additionally, Venus only reaches Earth every 584 days or so. These two characteristics combined ensure that while it's a spectacular and predictable sight, it also means we'll likely only have the chance to see it twice in our lifetimes. All planets orbit counterclockwise around the Sun, and in that, Venus is no different. But unlike all other planets, it spins clockwise on its own axis or, in other words, in a retrograde rotation. Not only that, but it has an extremely slow rotation, spinning once every 243 Earth days, slower than any other planet. This makes a sidereal day longer than a Venusian year lasting 224 Earth days. A sidereal day is one complete rotation of the planet. Due to this retrograde rotation, however, a solar day, which is from sunrise to sunrise, is considerably shorter, at 117 Earth days. As a result of the relatively long solar day, a year on Venus lasts approximately 1.92 Venusian days. To give you a perspective on how slowly it rotates, at the equator, the planet is spinning only at 6.5 kilometers per hour. This slow rotation makes it the second most spherical object in the solar system after the Sun. It's unclear why Venus spins backward compared to the rest of the planets, but it might be due to a large impact with another object billions of years ago, or due to tidal locking effects or tidal effects on the Venusian atmosphere. Its mass and size are very similar to our Earth's, hence it's often called the sister or twin planet. Venus is one of the 4 inner terrestrial planets and is a rocky planet. Its diameter is slightly smaller than Earth's at 12,100 kilometers, compared to Earth's 12,740 kilometers, and its density is 5.243 g/cm superscript 3 compared to our 5.514 g/cm superscript 3. This means that gravity on Venus is only slightly weaker than on Earth, with surface gravity being 8.87 meters per square second or 0.9 g. But that's where the similarities end. On the surface of Venus, the atmospheric pressure is 92 times greater than that of Earth. This is equivalent to 1 kilometer depth in Earth's oceans. The reason for this is because the density of Venus's atmosphere is 93 times greater than that of Earth. And cram that much gas into a space slightly smaller than what we have here on Earth, and you can understand why it's so densely packed. The atmosphere consists mainly of CO2 gas and, combined with sulfur dioxide clouds, you get the strongest greenhouse effect in the solar system, with temperatures averaging 462 degrees Celsius on the surface. This makes the surface temperature higher than that of Mercury, even though Mercury is the closest planet to the Sun and Venus receives only 25% of the solar radiation that Mercury receives. The difference is that Mercury lacks an atmosphere to retain heat, while Venus certainly has one. This means that during the night and even at the poles, the temperature remains relatively constant. Venus is really cooking, absorbing a lot of heat, but like a thermal balloon, it holds onto it and doesn't let much escape. With an axial tilt of only 3 degrees, it also means that seasonal temperature changes are very minimal. Wind speed isn't very high on Venus's surface, being only a few kilometers per hour, but due to the thickness of the atmosphere, it applies a very strong force on obstructions, moving small rocks and dust across the surface. On the other hand, wind speed in the cloud layer is much faster, reaching speeds of 300 kilometers per hour. These winds at the cloud tops circulate the planet every 4 to 5 Earth days, making the planet appear to be spinning much faster than it actually is. The cloud layer sits above the thick CO2 and consists mainly of sulfur dioxide droplets and sulfuric acid. Just as a side note, sulfuric acid is highly corrosive, and this acid rain only adds to the hellish nature of Venus, though it evaporates before reaching the surface. Clouds on Venus are highly reflective, allowing only about 10% of sunlight to pass through, and since they cover the entire planet, this prevents a clear view of the surface from space. These clouds are also capable of producing lightning much like Earth, though not as common. Recently, we discovered that Venus has a large vortex at the South Pole, much like Saturn. Venus is the image on the left and Saturn on the right. They have quite different shapes, and Venus has only one storm, while incredibly, each black dot in the Saturn image is a separate storm, with the main vortex in the center. The vortex on Venus sits at an altitude of 59 kilometers, just above the cloud cover. Which leads to an interesting point about Venus's atmosphere. At about 50 kilometers altitude, air pressure and temperature are tolerable.